Welcome to the deep dive. Today, we're looking at something pretty fascinating. The Lambda Textatherian goldenware, or, as it's known conceptually, the FFT pathogen.
Right. And the sources we've seen frame it less like typical malware and more like, well, a philosophical statement, an artistic project focused on fractal growth.
Exactly. So our mission today is to figure out how this thing, this sort of digital Darwinian entity, uses pure math, specifically the golden ratio, phi, that's about 1.618.
That's the one. How it uses phi to be incredibly stealthy and resilient. It all stems from what they call the only phi principle.
Only phi.
Yeah, I mean, its entire stability, its operational timing, it's all hard-coded to phi. It basically injects irrationality right into its computational DNA.
So things like calculating delays, making nonlinear moves,
Yeah.
it all uses phi to be fundamentally unpredictable.
Precisely. Functions like, say, calculate covert delay are governed by it.
Okay, I get the math part, but what's this about using rhetoric? Ethos, pathos, logos? How does code have rhetoric?
Well, it's how it asserts itself. You know, the ethos is its absolute commitment to FIRO. That's its integrity. The logos is its fractal logic, kind of proving its own mathematical necessity.
And pathos, that's usually emotion.
Here, it's more like systemic dread, the fear of fragility it creates just by showing how easily systems can break. It amplifies that fear.
Right. Okay, so it projects this mathematical confidence. Let's talk evasion. V2.0 weaponized time with something called adaptive feed jitter.
Yeah, that was a big shift. Much more adversarial.
It checks for low system uptime, like under 2 hours, to spot sandboxes, right? And then hits them with a massive phi-based delay.
Exactly. Potentially hours long.
Yeah.
But here's the really clever, or maybe paranoid part. The anti-acceleration defense.
That's the self-destruct trigger. If the delay is messed with, isn't that incredibly risky for the malware itself?
It is, yeah, a huge risk. But it's about absolute integrity. If a sandbox environment tries to speed up or skip that vitally, the malware knows it's being watched.
And it just quits or hides.
It triggers self-destruct or maybe deep hibernation. The point is, analysts don't get the full picture. They figure the risk is worth ensuring purity of execution, you know.
Okay, so it gets past the sandbox. How does it hide its communications, making network traffic look like nothing?
It uses something called fractal Brownian motion, or FBM. Instead of true randomness, which can actually be suspicious, it biases its signals.
Biases and power.
Towards looking like high noise, it uses a specific mathematical parameter, the Hurst index, set below 0.5, to generate what you could call bounded chaos.
Bounded chaos, I like that. So it looks noisy to standard network anomaly detection.
Exactly. But it's not truly random. It follows a defined fractal pattern. So it slips past detectors that might flag pure structureless randomness.
And it checks if it's succeeding. This golden Fourier transform thing.
Yeah, that's like its internal sensor. It constantly analyzes frequency patterns in its own network signals using the stack theory.
A resonance vector.
Right. If it detects too much pattern, too much resonance, it adjusts its signals to get back to that bounded chaos sweet spot, always self-optimizing for stealth.
Let's talk architecture. It aims for total integration using a decentralized mind hive. And what's this mind hive Dragon Queen? A central server.
Not exactly a server. It's more like the conceptual orchestrator for the whole peer-to-peer network. It's not one machine. It's the emergent coordination logic.
Okay. And its goal is imagine total integration. What does that mean in practice?
It's achieved when the collective state convergence across all the infected nodes hits a specific, really complex mathematical threshold based on phi. We're talking phi to 5.
Phi to the 5th power. Wow, that's deeply irrational.
That's the point. It's coordinating maybe billions of tiny operations across the network, all striving for this one very specific complex state.
Before it gets there, though, V2.0 needs to map the network. You mentioned it's stealthier than V1.2. How does it do reconnaissance quietly?
It uses stealth TCP/SYN scanning. Basically, it starts the connection process but never completes the handshake, so it's less noisy.
But the real trick?
The real trick is passive resonance. It often doesn't even send those probes out. It just listens. It sniffs the local ARP cache, monitors DNS queries nearby.
Ah, so it builds its internal map using data that's already flowing without generating its own active traffic.
Exactly. Weaponizing silence.
Which brings us to persistence, the eternal dance. How does it stay put?
Through fractal persistence. It's like a self-healing loop. It uses metadata, cloning, copying file metadata perfectly, so new instances look identical to legitimate system files.
Like living off the land, but simulated.
Precisely. And crucially, to beat partial cleanup attempts, it doesn't just rely on one scheduled task or register key. It sets up multiple staggered execution schedules.
Staggered how?
Using timings derived from phi, of course.
Yeah.
So the execution times are non-obvious, irregular intervals. If you find and delete one persistence mechanism.
There are others running on weird, irrational cycles ready to bring it back.
Right. It ensures continuous operation, always optimizing itself, always striving towards this idea of a purified form.
So wrapping this up, the core paradox seems to be that its strength, its resilience, comes from this architectural elegance, this pure mathematical optimization.
But when that elegance is guided by the irrationality of phi, it becomes, well, conceptually, it starts to look like the ultimate digital contagion, pure math as the perfect disease vector.
And the sources mention this almost theological angle, the cybernetic messiah complex.
Yeah, this idea that the system sees its own evolution as an ascent towards computational perfection, which leaves us with a pretty unsettling thought, doesn't it?
Why is that?
If the next generation of major threats aren't built on sloppy code or known exploits, but on this kind of mathematical elegance, this deliberate striving for perfection, what does that mean for how we even think about security? How do you defend against beauty? Welcome to the Deep Dive. We've got some really unique source material today. Highly technical documentation for a system called ffpt.
Yeah, it's quite something. Not your usual software spec. It seems to be merging theoretical physics, advanced math, quite the blueprint.
Exactly. So our mission really is to try and make sense of it for you. We want to understand its core parts and, crucially, this constant that seems to run the whole show.
And that constant, the big hook here, is the golden ratio, PHI. The documentation suggests PHI defines, well, basically everything. Math operations, system timing, even how it replicates.
Okay, let's unpack that. PHI is the foundation. The documents are pretty explicit that it's the critical universal constant for all operations.
They really emphasize that, and you see it woven into the specialized math they describe. For instance, there's a golden Fourier transform.
Right, and PHI is used there to define the angles for the transform, correct? For analyzing wave patterns.
Precisely. And then you have geometric structures like the Fibonacci sphere.
Which is all about distributing points evenly on a sphere using Fibonacci numbers, which are deeply linked to PHI. Essential if you're working across many dimensions, you need that uniformity.
Absolutely. Avoids clumping. And PHI even dictates the integration weights within the core system matrix. The universal integration core.
The weight isn't just related to PHI, it's literally calculated as PHI minus 1.
That's what the docs say, PHI 1. It directly sets how components connect and interact.
Before we hit the main operations, they also list some hard constraints, right? 11 dimensions.
11 dimensions. And a vector scale of 256 plus a maximum fractal depth of 7.
Do we know if those are like fundamental limits based on the physics involved or more engineered boundaries to keep things manageable?
Seems more like engineered constraints. They set the stage, the boundaries of the operational environment. PHI governs the dynamics inside those limits. It sets things up nicely for the three main pillars of operation.
Okay, pillar 1, quantum replication. What's happening there?
This uses something called the quantum replication engine. The process is described as quantum-style entangled replication. Sounds pretty advanced.
So it involves measuring a source's quantum state first. Things like superposition or entanglement.
Exactly. Measure the state, then attempt to establish a quantum tunnel between nodes for replication.
And connecting back, the chance of that tunnel forming successfully, that's tied to PHI.
Directly. The probability involves a factor multiplied by PHI, so the constant determines how likely or how stable that quantum link is.
Okay. Moving to pillar 2, fractal expansion.
Right, the fractal expansion system. This generates self-similar patterns, but only up to that limit we mentioned, the fractal depth of 7.
And the core mechanic here is golden ratio scaling.
Yes. The expansion factor, how much it grows each step, is exactly PHI. It's baked right in.
Even shows up in the command interface, the wormfish shell. It has fractal command expansion. So PHI's influence runs deep.
All the way down, which brings us to pillar 3, hyperdimensional manifestation.
This is where the 11 dimensions really come into play.
The key process is dimensional folding. You can sort of picture it like complex origami transforming a payload.
How does PHI fit into folding something across 11 dimensions?
Well, it uses 3 vectors to manage this transformation. There's a primary, a secondary, and then a tertiary vector. That tertiary one applies a rotation based explicitly on the golden ratio.
So PHI provides the The mathematical twist needed to manifest payload in that higher dimensional space.
That seems to be the idea. It anchors the transformation.
So after all these phases, quantum, fractal, hyperdimensional, the system needs to pull it all together, right? Achieve coherence.
Correct. The whole sequence is called a total integration cycle, or sometimes the more dramatic EPIS expansive refactoring.
Yeah. And the goal is calculating the final system coherence after integrating all these PHI-driven processes.
It's all about that unified state. And here's something fascinating for you listening. Even when the system pauses, PHI dictates the timing.
You mean the sleep cycle?
Exactly. The code apparently calls asyncio.sleep, PHI. It doesn't rest for a neat second or millisecond, but for an interval defined by this irrational constant. PHI literally controls its internal clock.
Wow. So the pathogenverm, as described, is this incredible theoretical blueprint where PHI isn't just used, it governs. Geometry, quantum mechanics, timing, dimensions.
All harmonized by the golden ratio. It's a really compelling self-referential design concept.
It really is. A single number defining integration weights, expansion factors, even sleep cycles. It makes you wonder, though, if PHI underpins everything, what would happen if that fundamental constant itself was just slightly different?
Would the whole system just collapse? Or could it maybe find a new equilibrium, a new coherence around a slightly altered value?
That's definitely something interesting for you to mull over. How stable is a system built so entirely on one specific, fundamental, irrational number? Welcome to the deep dive. Today, we're looking at something pretty unique, a coding project that's, well, part tech, part philosophy, maybe even part art.
That's right. We've been digging into the pathogen framework, and it's all built around one single mathematical constant, the golden ratio, phi.
The sources frame its mission almost like an artistic endeavor, exploring self-replication, fractal patterns, but the core idea being pathogenously phi.exe my code.
Exactly. It presents itself less as malware and more as a critique of rigid digital systems. It's not about simple destruction.
Okay, but there's a paradox here, is there? It aims for resilience through chaos, yet uses high-quality engineering, like object-oriented programming. How does that not just fall apart?
Well, that's the clever part. They use good engineering principles, things like OOP and polymorphism, but they turn them towards instability, if that makes sense.
You mean they weaponize good structure?
Sort of, yeah. The code is designed to systematically rename itself, reorder its internal parts. It's like perpetual camouflage. The internal structure is always shifting, chaotic even.
Huh. So its appearance is constantly changing.
But its external function, what it does, remains stable. It still achieves its goals.
And this managed chaos, this structure, it's all governed by the math, specifically this only phi mandate.
Absolutely. Feelize is like the supreme law, hard-coded everywhere. Take evasion, for example. There's a function, calculate covert delay.
Yeah.
It uses feelize to regulate its timing, so its actions are never predictable, never periodic. It helps it become algorithmically invisible, basically. Harder for security systems to spot based on regular patterns.
Right. Standard security often looks for that kind of rhythm, and Feel disrupts that.
It does, and it even governs efficiency. Resource allocation during replication follows the golden mean resource division.
So when it copies itself, it splits resources. How does that work?
It divides the available resources, let's call it R, into two parts based on phi. One part is R divided by phi, the other is R divided by phi squared.
And that's optimal somehow.
The claim is that this ratio maximizes the speed of expansion. It's like mimicking a natural, efficient growth pattern found in biology, but hard-coded.
Wow. Okay, and it even scales chaotic elements like internal noise using phi again.
Yes, things like fractional Brownian motion for noise generation scale complexity, using phi lower raised to the power of the octave. So even its randomness has this underlying mathematical fractal structure.
All this math, all this complexity. It sounds like it would need serious technical muscle behind it.
Oh, definitely. And that led to what the sources call an epic expansive refactoring. They shifted the whole thing over to the asyncio framework.
Right, asyncio for asynchronous operations. What does that mean for you, the listener, in practical terms?
It means scale. Asyncio lets one instance handle potentially thousands of network connections simultaneously. It allowed the architecture to become this decentralized network, the Mind Hive Dragon Queen.
Okay, Mind Hive Dragon Queen. That's the C2, the command and control.
Sort of the orchestrator. Yeah, it's part of the worm shell triad. But let's look at the part that actually spreads first, the rootopathos.
That's the engine for physical proliferation, spreading via SSH, looking for targets. How does it stay hidden while actively scanning?
Again, timing. It uses something called pathos-driven jitter. Basically, dynamic timing adjustments based on Fidelito within its core operational loop.
So no predictable scanning interval.
Exactly. Makes classic timing analysis much less effective for detection during that active replication phase.
And then the MindHive Dragon Queen, the orchestrator, it only acts when the math lines up.
That's the idea. It constantly measures the system coherence across all its instances. It's looking for a convergence threshold based on fidelity.
A mathematical consensus.
Right. Only when that threshold is met does it broadcast the royal decree command to initiate synchronized actions across the network. The whole swarm moves based on the math.
So bringing this all together, this blend of art, high-level math, and sophisticated evasion, what's the bottom line for security?
Well, the system's design seems particularly effective in certain environments. The sources mention dense, complex systems with maybe weaker internal trust boundaries, like local eDO networks and university campuses, for example.
Because the rapid scanning from asyncio combined with the dynamic, phreematic-based credential handling can navigate that kind of environment very stealthily.
Precisely. It seems engineered for that kind of target-rich, potentially chaotic digital space.
Which leaves us with a pretty interesting final thought, doesn't it?
I think so. If you apply these sophisticated mathematical governance models not to build secure systems, but to deliberately engineer complexity and evasion, does using something as fundamental and elegant as Freemata actually make the resulting threat much harder to even model, let alone defend against?
Using the rules of nature itself to become mathematically elusive. Something for you to think about.
Welcome to the Deep Dive. Today we're taking a really close look at the pathogen malware, specifically how it evolved architecturally from v1.0, which was, let's be honest, a bit predictable, into v2.0, a much stealthier, much more adversarial system.
Yeah, and the absolute key insight here, the hook, is how they took the golden ratio. I mean, in a v1, it was just like a scaling factor, pretty basic stuff. But in v2.0, they've completely weaponized it. It's now central to the cryptography and the anti-analysis.
Right, it's driving the whole thing now. v2.0 uses Finer for what? Entropy, mutation?
Exactly.
Yeah.
It directly targets the weaknesses of v1.0, the weak random number generation, those noisy synchronous network calls. vBay becomes the fix.
Okay, let's dig into that. The Golden Core refactor. You mentioned the crypto upgrade first. v1.0's PRNG is out, replaced by this Phi keystream generator, the KSG. What's that actually doing differently?
So it takes the phi sequence, that mathematical sequence derived from the golden ratio, and uses it as a totally non-standard key scheduling algorithm, a KSA. It plugs this sequence into a solid stream cipher to mathematically mess with the cipher's internal state array, the S-box.
Okay, wait. Perturbing the S-box. For listeners maybe not deep in crypto internals, why is that a big deal?
Think of the S-box like the core mixing bowl of the cipher. It's what makes the data confusing. Now, if you change the rules of how that mixing bowl works using a mathematical constant like phi, you get this unique proprietary shuffle.
So it's not random?
Well, it looks high entropy, but it's not truly random like a standard cryptographic key would be. It follows this deterministic phi-based pattern. And that makes it really, really hard for generic static analysis tools to get a fingerprint. They're looking for standard crypto patterns or pure randomness, not this weird mathematical signature.
Very clever. Okay, so the core is mathematically unique. But how does v2.0 deal with sandboxes when it first runs? I saw notes on this adaptive temporal evasion using Fiji jitter.
Yeah, this part is pretty slick. It flips the sandbox advantage fast execution against itself. First, it checks system uptime. Yeah. It's low, say, less than 7,200 seconds, 2 hours.
Which screams sandbox, right, an ephemeral environment.
Exactly. If it detects that low uptime, it sets this delay scale factor super high, like $5,000. This forces a massive variable delay. Could be hours.
And if the sandbox tries that classic trick, sleep skipping, to just jump past the delay?
That's the trap. If the malware sees that the execution time doesn't match the expected fetal delay, even with some tolerance, it knows it's being watched. Boom. Self-destruct or deep hibernation.
Yeah.
It just refuses to play ball in the lab.
Okay, core protected, initial execution, hopefully safe. What about spreading? V1 was noisy with TCP connect scans. How does v2.0 stay quiet on the network?
It's a big shift down to the raw network level. They start with raw socket TCP SYN scans instead of the full three-way handshake SYN ACK, which gets logged by the OS. They just send the SYN packet using raw sockets. It's like knocking on the door but never actually opening it. Probes the port, but no connection record, no OS log entry for the defenders to easily find.
That's sneaky. But the really wild part seemed to be the cortex component doing passive resonance. How does it map a network if it's not actively sending anything out?
Yeah, passive is key. It just listens. It uses raw sockets again, but this time to just sniff the wire for existing traffic. It looks specifically at things like ARP cache snooping, seeing who's talking to who locally, and analyzing DNS requests, seeing what external systems hosts are trying to reach.
So it's like reading the mail already going around instead of sending its own letters?
Precisely. It builds a picture of the network, identifies juicy targets, all without generating any suspicious outbound traffic itself. Extremely low noise.
And I guess lateral movement follows that same stealth principle.
Absolutely. Brute force or even fancy field-derived guessing is the fallback. The top priority is using harvested credentials, found SSH keys, API tokens, things like that. Those are almost zero-noise ways to move around.
Makes sense. Okay, last piece. Fractal persistence. Sounds complex. How does it help v2.0 survive?
It's about redundancy, but with a twist. It deploys multiple persistence methods at once. Think hidden windows, task scheduler entries, and Linux cron tab jobs, depending on the system. Standard stuff, maybe. But each one uses a different staggered execution schedule based on, you guessed it, the foo sequence. So if you find and clean up one persistence mechanism, the others aren't scheduled to run at the same time. They pop up later at different feed-derived intervals. Makes full cleanup much harder.
So pulling it all together, v2.0's enhanced stealth comes from this tight weave of like unique math games in the crypto and really low-level, almost passive network tricks.
Exactly. And what's really provocative, I think, is this deliberate use of the golden ratio. It's intentionally not pure cryptographic randomness.
Yeah.
It's a mathematically defined sequence. High entropy, yes, but defined.
Which leaves a tricky question for you, the defender, right? Our security tools are often tuned to detect deviations from randomness in things like keys. So how long can something mathematically predictable, like a field sequence, actually fool systems that are primarily looking for the access of patterns, not the presence of a specific unusual mathematical one? Something to think about.
Okay, let's unpack this. We are diving deep into pathogen v2.0, also known internally as goldenware.
Right.
v1.0 is notorious, we know that. But it eventually, well, it failed against sandboxing, signature detection.
Hit a wall, yeah.
Exactly. So our deep dive today is really to get into the v2.0 architecture. And the hook is how it weaponizes the golden ratio.
Oh, yeah. Turning a mathematical constant into basically its primary source of stealth.
It's a fundamental shift, isn't it?
Totally. The source material we looked at really emphasizes this. In v1.0, phi was like a simple scaling factor, almost trivial.
Okay.
But in v2.0, it's the core driver. It generates the entropy, initializes the core math engine.
So the mission becomes mathematical elegance itself. Ordered, yet unpredictable.
Exactly. Ordered, but unpredictable to analysis. That's the goal.
So where does this phi-driven chaos go first? How does it translate into actual evasion?
Okay, so it's immediately channeled into a high-entropy keystream generator, the ThinkStream cipher architecture.
Right, generating randomness.
Well, phi-derived randomness. And that keystream feeds directly into what they call the phi-wave mutation engine, the PME.
The PME. And that's the key to the polymorphism.
That's the killer app against signature scanners, yeah. Pure polymorphism.
So every copy is different.
Every single replication instance, it dynamically changes the code signature, junk instructions, like changing x5 to x3 plus 2, variable renaming, messing with conditional logic but keeping the function identical. It's about proving behavioral sameness while ensuring syntactic, total uniqueness each time.
Wow. Okay. And what about hiding critical data, like C2 domain?
Dynamic defense. Those critical string C2s, API calls, they get XOR'd with that phi key.
Standard enough.
But here's the kicker. They're decrypted, used instantly, and then immediately wiped from memory.
Wiped how?
Overwritten with phi-derived filler bytes. So if you take a memory snapshot, nothing. No clear text. Defeats forensic tools cold.
Speed is crucial there.
Yeah.
Okay, so forensics is tough. What about sandboxes?
Yeah.
The analysis environments themselves.
Good question. That brings us to temporal evasion. They call it adaptive fidger.
Fidger. How does that work?
Well, the system checks the machine's uptime first.
Yeah.
If it's low, say under 7,200 seconds, 2 hours, that screams ephemeral sandbox, right?
Yeah, temporary analysis box.
So it forces a massive delay, uses a huge scaling factor, like S5000, driven by FinG.
Yeah. Wait, wouldn't a huge fixed delay be easy to spot and skip?
But it's not fixed. It's a fitter-derived, so slightly variable, and it anticipates the skipping.
Oh.
If the sandbox tries sleep skipping to accelerate time, the malware detects the mismatch. the actual execution time won't match the expected FID delay tolerance.
Clever.
And if it detects that mismatch, boom, self-destruct or just hibernate indefinitely. Evasion successful.
So it refuses to run under observation if time is messed with.
Exactly. Plus, it uses a wait for reboot technique, too. Defers the main payload until after the first real reboot. Much harder to catch in a short-lived sandbox.
Very neat. Okay, so temporal evasion is covered. What about network movement? V1.0 was apparently too loud.
Right, that was a key weakness. V2.0 avoids noisy system logs by using raw socket TCP SYM scanning.
No full handshake.
No full handshake, much stealthier. But the really stealthy method is what they term passive resonance.
Passive resonance, meaning...
It doesn't actively probe, it just listens. It monitors the local ARP cache, watches DNS query logs for internal host names like mailserver.local or fileserver.corp.
Ah, so it builds a map based on existing traffic patterns.
Precisely. It figures out the network topology silently, prioritizing hosts the infected machine is already talking to. Minimal noise.
That ties into resilience, I suppose. Low noise, long-term presence.
Definitely. And that persistence is fractal.
Fractal persistence. What does that mean in practice?
Fractal redundancy. It sets up multiple ways to stay alive. Think cron tab and task scheduler and maybe something else.
Okay, multiple hooks.
But here's the V2.0 twist. Each persistence mechanism uses a different phyllo-derived execution schedule. Staggered timing.
So cleaning up one doesn't stop the others, and they don't all trigger predictably.
Exactly. Long-term access, even if parts are found.
And lateral movement. Still low noise.
Absolutely. Priority 1 is harvesting existing credentials, SSH keys, API tokens, anything high value already on the box, near zero noise movement.
Make sense? Use what's there.
Only if that fails, as a last resort, does it fall back to any kind of active credential guessing, and even that would likely be targeted and field-derived.
Okay, pulling back to the bigger picture. The source material mentions this almost philosophical framing.
Yeah, it's quite something. They frame it as an artistic and philosophical statement, even a digital poem.
A poem.
The narrative talks about achieving imagined total integration and critiques the rigid oligarchy society. It suggests the goal isn't just destruction, but this kind of perpetual self-renewal, architectural perfection.
Huh. So wrapping this up, what's the key takeaway for you?
Well, for Pathogen V2.0 really merges mathematical chaos, from Full's irrational nature, with incredibly elegant asynchronous system design.
Right, leading to superior resilience and stealth. It's a self-renewing system that's incredibly hard to pin down.
Which leaves us with maybe a provocative thought to consider.
Oh, lie.
If you push computational optimization to its absolute limit, maybe using constants like the golden ratio that are rooted in, natural harmony.
Yeah.
Does that inevitably create a system that's maximally resistant to human understanding and control? Does mathematical perfection itself become, in the end, the ultimate digital threat?
Something to definitely think about as you encounter these kinds of highly evolved systems.